Hello and welcome, my dear students, to my channel Mathematics Made Easy. This is Ms. Ruchika welcoming you to today's session. This video is much awaited by all my grade 11 advanced math students who are going to give the exam next month. So from my side, I wish you all the best. And let's start with today's video. This is the first video for your EOT exam coverage, in which we are going to be focusing on learning objective number 1 and covering questions 17 to 34, which are given on page 222. So let's start and learn how to graph exponential growth functions. This video is a must-watch video for all of you who are going to prepare for the exam. I hope it helps you, and if it does, do subscribe to my channel and press the bell icon so that you don't miss my upcoming videos. So let's get started and see the most important questions from EOT for this topic. Okay, so as you see, the first question that we are going to be covering is from module 5, lesson 1, in which you need to determine whether each function represents exponential growth or exponential decay. So for these kind of questions, from question 17 to question 22, we are going to be using a key concept, which I will write for you now. And the same key concept will help you solve all the questions from 17 to 22. So let's understand the key concept. Okay, so this works for question 17 to question 22. So what is this key concept? In this question, we are focusing on exponential functions. So let me give you the general form or the formula. So the general exponential function fx is denoted by the base b raised to the power x, or the exponent x. Now, the value of the base decides whether it's going to be an exponential growth or an exponential decay function. So let me give you both the cases and then we solve this question together. So it's going to be exponential growth. That means it's going to be an increasing function if the base is more than 1. And on contrary, opposite, it will be an exponential decay function or decreasing function if the value of the base is lying between 0 and 1. So if it is less than 1, like a fraction, say 1/2, or it's a decimal like 0.5, which is less than 1, it's going to be decreasing or exponential decay. So let's now cover these questions one by one. Now we are ready to compare. So for question number 17, if you look at the base is the number to which the variable x is raised. So the base here, just compare it with this general formula, so it will become easy for you. So the base here, which is the value of b, is 7, and definitely 7 is more than 1. So which one it is? Yes, you are right, my dear students. It's a question on exponential growth. So that is what you have to do in this question basically. Let's come to question number 18. I'm going to write it here for you. Tell me, what is the base? The number to which you have the power x raised. So the number here is 0.99. It's a decimal and definitely it's less than 1. So this is going to be an exponential decay function. So the graph is going to be decreasing. Okay, in a similar way, let's now do 19th question. So for this one, the base is a fraction. It is 2 divided by 3. And always, you can convert the fraction anytime using your calculator to decimal. And you will be very sure that it is going to be less than 1. So this is also a exponential decay function. I hope you've understood these questions 17 to 19. So let's complete these kind of questions and also do the remaining from 20 to 22. Okay, now, so in question number 20, the base is a fraction and it is equal to the value 5 divided by 4. It's a fraction. So you can always convert it to a decimal using your calculator. In your exam, scientific calculator is allowed, so this will be easy for you to judge that this base is definitely more than 1. And when it is more than 1, it is an exponential growth function. Well done. Okay, let's finish this up with the last two questions of this kind. So if you see now carefully, for question 21, The base is 0.75. It's a decimal and definitely it is less than 1. So if it is less than 1, it becomes exponential decay. The graph is going to be decreasing in nature. Wonderful. Let's proceed. Next question. Question 22. What is the base here? The base is 1.02, and this goes without saying. It's very obvious that it is more than 1, and hence this is a function which is increasing and it's a exponential growth function. So very easy start to our today's video, and I hope you've understood these questions 17 to 22, and here I provide you with the detailed solution. So this is the solution set, the answer key for question 17 to question 22. So well done. Let's proceed further and cover some more questions which are going to be from learning objective 1, where you graph exponential growth functions. Okay then, so let's move to the next slide. Now in these questions from 23 till question number 26, yes, till these questions we are going to be following the same method. Now these kind of questions I'm quite pretty sure that are going to be asked in your paper-based exam. So you need to show your steps, you need to show your working, and as you know, graphing calculator is not allowed. So you have to do the table of values when you're trying to graph such a function. So let's do it together. For this you will definitely need your calculator so that you are able to save some time. So we are going to start with question 23. Same method will be followed for question 24, 25 and 26. Okay, so let's see what we need to do here. So the first thing we need to do is to graph the function, and for which I already told you we are going to follow the table of values method. Each step for your paper-based exam carries marks, so make sure you are showing all the steps, you are showing all the working very nicely. And further, after you get the graph, you have to give us the domain, the range, the y-intercept, the asymptote and the end behavior. So there are going to be steps for each of these parts. So make sure, again I'm repeating, you show your working very well if this comes in the free response or the paper-based exam. Okay then, so let's proceed and make the table of values. Please take out your calculators so that you can do this with me. And as I have told you many times in my class, my students know this already, for drawing the graph of an exponential function, whether it is growth or decay, we are going to take at least minimum is 6 points. Okay, so we'll draw these 6 points on the graph sheet and then we will connect them to make the graph. Okay, so let's do it. So generally we take some negative, some positive and definitely 0 points. So we are going to begin with the point -3. Move to -2, -1, 0, 1 and 2. So these are how many points? Let's count. 1, 2, 3, 4, 5, 6. So well enough, good enough. We will mark these 6 points, and now comes the role of your calculator. I want you to plug in your calculator these numbers and give me the fx value. I hope you know that when you are doing this on your calculator, this is the fx value you're going to put, and just keep on changing the value of x and get your solutions. Okay then, so let's do this. And one more point which I would like to highlight here before we proceed is that in this question, before even you draw the graph, you know the base is 0.25, which is very less than 1. It's definitely less than 1. So even before you draw the graph, you know that this is going to be a decreasing graph. It's going to be an exponential decay graph, and that is how you can do it in a more quicker way. Okay, so when you plug in, I'm sure you got some value. So this will come out to be 64, 16, 4, 1, 0.25 and approximately 0.06. So I put this symbol to tell you it's an approximate value. So what are the points you get? You get -3, this is the x value, y value 64, then -2, 16, then -1, 4, 0, 1, 1, 0.25 and 2, 0.06. So 1, 2, 3, 4, 5, 6. Okay, we have these 6 points. Now we are going to graph these 6 points. We're going to draw these 6 points on the graph sheet and then connect them with the dots. So let me make a rough graph for you. So this is my x-axis, this is my y-axis, this is the origin, you all know. So let's first make the easy point, which is this one. And if you see at this point, the x value is 0, the y value is 1. So definitely this point is going to lie on the y-axis. So this is the point 0, 1. I draw it. And similarly, you can make equal divisions. This is positive y-axis. This is negative y-axis. Make the divisions. This is positive x-axis. This is negative x-axis. Now I'm drawing it with free hand, so it may not be looking as perfectly equal, but then if you use graph sheet and if you use ruler and pencil to do the graph, it will become more easy. Okay, perfect. So now you have this point. Similarly, you draw another point. Like for example, I'm taking this point next, minus 1, 4. So minus 1 is here. 1, 2, 3, 4. 4 is here. So it's going to be this point. Similarly, let's do one more point. I'm taking 1, 0.24. So x is 1, y is 0.24. So it's going to be this point. So in a similar way, you draw all the points. So this is 2, this. So it will be more below. And then you take the pencil and join these points. So I join this, this, and this. So the graph will come like this. And this side it will go up. So as you can see, it's a decreasing graph, right? It's an exponential decay graph. So this is done, the first part. Now we need to give domain, range, y-intercept, asymptote, and end behavior. So let's do that one by one. Let's talk about D. D is the shortcut for domain. So domain, as you see, this graph is taking negative x value, 0 x value, and positive. So it will be all real numbers, all are included, positive, negative, 0. You may also use minus infinity to infinity if you want to represent an interval notation. That's also correct, you'll get marks. Or you want to just write capital R representing all real numbers set. Everything is okay here. Let's come to range. Now the range is coming from the y values, the domain is coming from the x values. I hope you remember that. If not, you can keep a note here. So for y values, let's see what y values is the graph taking. Can you see the whole part of the graph is above the x-axis here? So the y values are all positive real numbers. There's no part of the graph that is below the x-axis. So therefore you may just write for your range the numbers 0 to infinity. Now is 0 included? Yes, definitely, because when x is 0, y is 1. So you can make a closed bracket and open. Okay, so domain is done, range is done. Let's look at y-intercept. Y-intercept by definition is the point where the graph touches the y-axis. So definitely this graph is touching y-axis at this point 0, 1. So your y-intercept. So there are two ways of writing. Either you write the point 0, 1 or you just write the y-intercept, which is 1. Both are acceptable, both are okay. You'll get your marks. Okay, next point is asymptote. Now by definition, my students know it, but for anybody who doesn't know what is the meaning of asymptote, let me recall for you. So asymptote is that line which the graph approaches. So if you see this graph is approaching, it is coming very, very close to the x-axis. I want you to, let me just highlight it a little bit for you. I want you to observe this part of the graph. Oh, let me just change it a little bit here. Yeah, I want you to observe the part of the graph that is almost very, very near to the x-axis, this part. So this part is very close to the x-axis, therefore x-axis is the asymptote for this graph, because in this part specifically the graph is coming very close to the x-axis even though it is not touching. So you may say that the asymptote is the x-axis, or you can write the equation of x-axis. So I hope you know that the equation of x-axis is y = 0. So both will work, both will give you full marks. Okay, now let's come to the last part of the question, which is your end behavior. Now, many of the girls that I know have a little confusion in this, so I want you to pay more attention when I'm explaining you the end behavior. So, end behavior is how the graph behaves at the end point. So, what are the end points of the graph? This is one end point. This part is another end point. So, let's look at them one by one. So, first we look at the left end point. This is the left. This is the right side of the graph, right? So on the left side, can I say x is negative? So we write as x goes to minus infinity. Where is the graph going? It's going up. So up is positive y. So we would say fx goes to plus infinity. This is the end behavior on the left side, left end behavior of the graph. Let's come to the right side. So on the right side, definitely x is positive, so x goes to plus infinity, and then my fx is going very, very close to the x-axis, and we already know the equation of x-axis is y equal to 0, so fx is going to come very, very close to the point y equal to 0. So that completes this question. We have graphed the question, we found domain range, y-intercept, asymptote, and end behavior. And if you show all your steps and work it out like I just told you, you're going to get full marks in this question. Okay, so let's now do the next question, which is question 24. Again, in this question, we have exponential decay happening. As you see, your base is less than 1, 0.8. So we know before we draw the graph that it's going to be a decreasing function. So because calculator is not allowed, the graphing one, only scientific is allowed. So we'll make the table of values, we'll plot the points and then join them to draw the graph, just like we did for the previous question. So I'm choosing the same x values, some positive, 1, 0, and some negative. So all the values we are taking, this one is negative, this one is positive values. So use your calculator, plug in this function, get your values. So the first point is minus 3, 1.95. The next point is minus 2, 1.56. The next point is minus 1, 1.25, and so on. You get all the 6 points. Now you're going to go to the graph. This is the graph sheet. If a graph sheet is there, your job becomes easy. You don't have to waste time in drawing the axis and the partition. So this is a good thing. So you plot the points. The first and the easiest point is 0, 1. This is also, if you see, the y-intercept, because at this point x is becoming 0 and this graph is touching your y-axis at this point. So y-intercept is 0, 1 or 1, as you see here. Again, for this graph, the domain, as you see, is all real numbers. It is taking positive, negative, 0, everything. So this is the answer. Or as I told you in the previous question, you may also give these two options as your answer. It's all accepted. Then all positive real numbers can be written as 0, infinity. Remember, 0 is closed because at x equal to 0, the function is defined. Y is equal to 1 or fx equal to 1. So your range, which is coming from y-axis, becomes all positive real numbers. Y-intercept we've already done. Again, the asymptote is the same graph. If you see this part, the graph is coming very, very close to the x-axis, and the equation of x-axis is y equal to 0. So this is your asymptote. Last part is end behavior. So I will explain you here on the graph. This is negative x-axis, this is positive x-axis. So where is this graph going? It's going up. So as x goes to minus infinity, I put the sign minus infinity because we are on the negative side of the x-axis. Where is y going? Where is fx going? The function given is fx, so I will use fx. It's going up, so it means it is going to plus infinity. So this is the end behavior on the left side. Let's come to the right side. On the right side of the x-axis, definitely your x is going to go to plus infinity. It's positive. So where is my fx going? Let's see. Fx is coming very close to the x-axis. So again, like previous question, it's going towards 0. It's going near and near to the x-axis. Okay, so that completes question 24. Let's do one more to make you confident in these kind of questions. So the next question we are doing is question 25. Again, I'm going to go now a little fast because it's the same steps we are repeating. So girls, boys, please understand, if you are understanding the method of doing a question, whatever number comes in your exam, you will be confident. So don't focus on learning the answers, focus on understanding the question and the method. Okay, so with that, let's look at the base. Again, it is less than 1. So even before I draw the graph, I know this is an exponential decay question, so the graph is going to be decreasing. Follow the same steps, make the 6 points, use your calculator to get these values, plot these points, get your graph, and then let's do the domain, range, y-intercept, asymptote, and end behavior. Now, I'm sure by now you've got good practice and you know that the domain, the range, the y-intercept and the asymptote will be same as the previous question, because the last two questions that we did, question 23 and 24, they were also exponential decay question. They were decreasing, so these things are not going to change. Let's think about the end behavior. Is end behavior going to change? Think about it. Here this side on the negative x-axis, again the graph is going up, so this end behavior is going to be same. And on the right side it is coming close to x-axis, so the end behavior is same here also. Okay, so that completes question 25. Let's proceed and do some more questions now. Okay, so let's do the next question now. Here we have to graph the function fx equal to 2 by 3 to the power x. So I have put here the solution for you. Again, the base is less than 1, so it's going to be a decay function. So I hope by now you're confident in this method. We do the same thing. We take the table of values, we take 6 points, join them, get the decreasing graph, and find the domain, the range, the y-intercept, the asymptote, and end behavior. And as you see, for these same kind of decay function, all these points are almost the same. Okay, so let's now proceed further and move to next kind of questions, where we are now introducing the concept of transformations. Okay, so there is a key concept that we will be using for these kind of questions. That are question 27 till question 32. Yes, we are going to use the same method. So let me give you the key concept, explain for you, and then you will be able to solve these questions very, very nicely. So this is the key concept. So when I say key concept, you have to remember it, the formula and everything, and use it to solve the question. So the key concept is that if your function is given by a times b to the power x minus h plus k. Okay, so this is the transformed function, and for this the base function is definitely your exponential function. So b to the power x. Okay, so if this is the original graph of the exponential function, it can be growth, it can be decay, and we transform it, we change it, then this is the new formula that you have for the transformed, for the changed, for the new function. So what are these a, h and k? Let's find these variables a, let me change color, a, h and k for these three kind of questions. If you're able to identify them correctly, then half of the question is already solved. So let's do it. So let's compare. So I hope you're able to compare. For the first question, a is -4, h is the one which comes with x. So here we are comparing x minus h with x plus 4. So your h is going to be negative. Similarly, k is the number which is outside, not involving x. So k here is plus 3. Okay, so we've identified these three variables for question 27. Let's do similarly for question 29. For question 28, you can do similarly. So a is the number which you see outside, so it's 1 by 2. H is the one that comes with x, so it's -5. I hope you're able to understand why it is -5 and not +5, because we're comparing x plus 5 with x minus h. So when they have opposite signs, it is negative. Okay, similarly your k is 8. Now what are these A, H and K? I hope you remember that A tells you about dilation. H tells you about, let me write here in fact, A is referring to dilation, and the value of A decides whether you are going to stretch the graph, whether you are going to compress the graph, and also if you have a negative sign like this one, then the negative sign tells you that we are also going to have reflection about x-axis. Okay, so if you get such a question in the multiple choice and you have to select all the correct transformations, then for question 27, 28 and 29 you have to pick all the correct options, which are reflection because it is having a negative value. Then also because your value of A is more than 1 here, if you take the absolute value, it's going to be +4, which is more than 1. So therefore the graph is going to be stretching vertically. There's a table of values that has been given to you in this lesson. I think this was lesson 5. Let me just confirm you. This was from lesson 5.2 if I'm not wrong. So just you can check your book and you will get that table of formulas that work for transformations. Okay, then H is your horizontal translation, and when H is negative, definitely you move left because your horizontal axis is x-axis. So horizontal translation, and how many units? 4 units. Okay, so H is your horizontal translation. How much you're moving? Horizontally. So you move to the right if H is positive, you move to the left if H is negative. So here also you will move to the left side. Let's look at the last component, K. K is your vertical translation. So vertical axis is Y. So there are 2 options, either we go up or we go down. So if K is positive, we go up. If K is negative, we go down. Similarly, if H is positive, we go right, positive x-axis. If H is negative, we go left. Okay, for dilation I already told you. So here we are going to move 3 units up, and here we are going to move 8 units up. Okay, now what is the difference in question 27 and 29? If you see carefully, the value of A is different. In question 27, the value of A is more than 1, so you get the dilation that it is going to stretch vertically. However, in question 29, the value of A, if you take absolute value here, is less than 1, is 0.5. So the opposite is going to happen. So here, if it is stretching, here it is going to compress. And it will compress in which direction? It will compress vertically. Notice here the value of A is positive, so no reflection is happening. Reflection only happened in question 27 where A was negative. Okay, so this is how you do the transformation. And for graphing the function, again I would suggest you to make the table of values, get 6 points, join the dots and get your graph. Okay, so let's proceed now and do question 30, 31 and 32 also. And now I will go a little fast because I hope you've understood how to identify A, H and K. So A is how much? 3/4. It is less than 1, more than 1. The side? Less than 1. So if it is less than 1, we are going to compress vertically. H is coming with X, so it is -4. So we are going to move in the left direction by 4 units. Then your K value is negative this time, -2. So we will move down vertically along the y-axis by 2 units. So these are the transformations for question 30. Similarly, I would want you to try for question 31 and 32 also. And now I will give you the correct answers for these parts. So the value of A for question 31 will be -12, and the negative sign tells you there will be reflection happening along the x-axis, and because the absolute value is less than 1, we are going to compress vertically the graph. Next is value of h, which is -2, so we go left by 2 units. And finally your last value k, which is positive this time, so we go up on the y-axis by 9 units. Let's finish the question with the last part where you have a as -5/4. So reflection will happen because of the negative value through the x-axis, and because this time absolute value of a is 5 divided by 4, which is more than 1, so we will have the graph stretched vertically. I want you to notice that when a is less than 1, we are compressing vertically, please remember, and when a is more than 1, we are stretching vertically. So both are opposites, don't mix them. H is -4, k is +2, so we go left horizontally by 4 units and we go up by 2 units. Okay, so that completes the question. Please also draw the graphs so that you get the correct final solution. So now I will provide you the correct answers. So you can check with this answer key for question 27, 28. These are the final answers along with the graph. And these are the final answers for question 29, 30, followed by question 31 and 33. So this is all in learning objective number 1, graph exponential growth functions. So that brings us to the end of today's session. I also wanted to include question 23 and question 33 and 34 in this video. However, it was becoming pretty long. This video has become almost more than 30 minutes, so I don't want to make it more longer because it's difficult to watch long videos. So what I'll do for you is I will make another video which will cover specifically question 33 and 34. These are one of the most long questions from the EOT and they require great attention. So please, I request you, do watch the videos till the end. I'm taking out a lot of effort to make these videos for you and I hope you found it useful. And if you like the video, don't forget to like, share and subscribe to the channel. Also press the bell icon so that you don't miss my next video, which is going to be up on my channel very soon, where I cover question 33, 34 and so on from the EOT. So all the best to all my grade 11 advanced students who have watched this video. A big thank you if you've reached to the end of this video. It means a lot to me and I hope I helped you in your journey of learning mathematics and preparing well for your coming math exam. Until then, this is Ms. Ruchika signing off from today's session. See you in my next video. Bye-bye, students.